Today we're going to look at how we represent different expressions and how those representations help us to make sense of what they mean, what each of the operations mean. And so on the last few slides, you went through these next three slides here, and I want you to think about what you wrote. That was a little bit away for you to start thinking. And there's no right necessarily one right way or one correct answer here. You can see it in a number of different ways. The ways that I'm going to highlight right now are going to or the ways that I'm going to show right now are going to highlight the meanings of the operations and help us to make sense of and to hopefully explain why we have this order of operations and why that exists without the use of PEMDAS. And not that, again, PEMDAS is not that it's incorrect or that it doesn't work. That is absolutely not what I'm saying. What I want us to do is understand the order of operations without PEMDAS, because that's not helping us to understand what is going on. The understanding the order from the meanings of the operations is what is so important here. Just like same thing what we did with fractions, right? We were understanding it. We, in our head maybe think about it, or maybe you've been told it's parts of a whole, but as we keep working with it, we saw how limiting parts of a whole is, right? How problematic that can be. If I'm only thinking about fractions between 0 and 1, I'm missing out on an infinite number of fractions, right? So this is kind of that same vein of an idea, is that we want to provide our students with a conceptual understanding of what it is we're talking about and why math actually makes sense. Because for so many of us sitting in the classroom, we were told, well, this is just how you do it, without the whys and the why does that make sense, or why does it work that way. So here, maybe you thought of something, and maybe I hope that you did, right? Maybe this looked like a 3 by 4 array, right? So we can see this as 3 times 4. An expression means that you don't need to have that equal sign. Or maybe you saw it as 3 plus 3 plus 3 plus 3, right? Again, these kind of meanings. Or maybe you saw it as 4 plus 4 plus 4. And so here we can start to begin to recognize that 3 times 4 can be seen, right, as this repeated addition. And so this meaning, or we could even think about it as, right, oops, where did my pen go? Right, 3 groups of 4, or in this case, right, 4 groups of 3 if we're looking at each column, right, versus each row. And so that's, all of those are important, but what I want you to notice here is that this multiplication of a 3 by 4 or 3 times 4 has these different meanings. Oh, I'm sorry, I accidentally clicked on the next slide. There we go. So as you know, so I'm going to clear this for a second, and now I hope that you see I'm going to change the slide here. And what changed, right? What do we see? We saw this, maybe we saw it as this 3 by 4 array. So I'm going to write my 3 by 4, but I hope that you notice, right? We just then tacked on, right? We just combined, we just added, yes, added, literally added these 2 extra, right? 2 extra just added on. And that's important idea to notice, because we can now start to see the difference between what does it mean to multiply if we're thinking about the orange, and then maybe I can try to color code it, right? I don't have the purple or the orangey color, but I'll go as close as I can, right? Then what does it mean to add, right? And we can see that any number here that we just put, we can just put right here, maybe there were 4, maybe there were 6, maybe whatever. If you just tacked it on, right? It's just like literally you just tacked it on. It's just adding it. And so that's how we get this +2. And so now you're like, okay, Dr. Swartz, big whoop-de-doo. But what I really want you to focus on, I'm going to erase some of this notation now, or annotation or whatever it's called. What I really want you to see now, pretend we just had this expression. I'll write it in green, 3 times 4 plus 2. Again, I can't, maybe if you have different experiences than me, that's completely fine. I just remember, being in middle school probably and talking about, well, the multiplication has to come right before this addition, and because the M comes before the A, right, in PEMDAS. But you're like, but that like doesn't make a ton of sense as to why, like, oh, who just did this come down, from the heavens, that this is the way it is. And so what we can see here, though, through the meanings is that this is saying 3 groups of 4. But this plus 2 is not. This is just those 2 that are just chilling added on. So we would never want to do this 4 plus 2 first, because that would mean if we did the 4 plus 2, that would be 4 groups, right? Or maybe if it would change it to be 3 groups of, right, 4 plus 2. And notice now you bring in these new symbols, right? These parentheses. And so I'm going to clear some of this. Sorry, it's a lot of mess here. Just to try to help us to maybe I'll keep this here, right? This 3 groups of 4. There we go. And so now think about it like that. If this was 3 groups of 4, if we wanted it 4 plus 2, we would have to add in those new symbols. If we don't, right, then we leave it as 3 groups of 4 like we have, and then we just add on those last 2 here at the bottom. And so it's not that we do this multiplication first because of PEMDAS. We do this multiplication first, right? 3 times 4 because of the meanings of multiplication. This 3 times 4 is not a 3 and a 4, right? It's 3 groups of 4. Or we can even think about it as, right, 4 plus 4 plus 4, and then keep that, I'll put that 2 in green here. We'll just leave it right here. Leave this, bring it right down. And now we see if we rewrite the expression that way, there's not even a 3 in there. Or again, we could have made it 3 plus 3 plus 3 plus 3, and then we'll change the color. We'll keep that, 2 on the outside just chilling. And if we did that, look, now there's not even a 4 in there. And so this is what I mean by the meanings of the operations. And so, okay, so let that sink in a little bit. I know this is going to probably be the first time you ever hear anything like this. So just keep bearing with me and know that over time that this is going to start to make sense. And so now look what changed here. I'm going to try, these aren't going to match the colors exactly. We have 4, right? 1, 2, 3, 4. And 2. And what's happening if we just looked even at that first row, right? They're just put together. They're right next to each other. So this is where we get this plus. But now we see 4 plus 2 is not 1 time, not 2 times, but 3 times. So again, we're going to introduce these new symbols, right? The parentheses. And now we get 3 times not just 4, but we literally changed the groups, right? It's not just 4 with the 2 extra at the bottom. We had now changed the groups. So it's 3 times 6, right? 4 and 2, 4 and 2, 4 and 2. So it's 3 times 4 plus 2. But right now we have these parentheses. We want to add the 4 plus 2 first. And so the parentheses, right, changed the groups, right? Because the meanings of multiplication are these groups of, and if we put the parentheses in there, it doesn't mean do this first. It means I'm changing the groups, right? Again, PEMDAS is telling us, oh, P means we do that first. No, it just means I'm changing what's happened, right? What would normally be thought of as groups when you're thinking about like 3 times 4. All right. So that was kind of just one example to get you really thinking about it. And here now I put this two examples side by side. And so we can literally see the difference. On the left side, we have this 3 times 4 plus 2, right? This little 2 just at the bottom. And we see that's not the same as this 3 times 4 plus 2 right here on the right side because, right, we have 3 groups of, you can call it 6 or you can call it 4 plus 2, where here we have, right, 3 groups of 4 with, those 2 extra or added on, right? Or just, put at the bottom. Okay, so take a look at this representation. And again, think about what we've been talking about, the meanings of the operations. I hope you see it looks very similar, and maybe you're immediately jumping to exactly how you thought about it before, right? I see this array of 3 by 4, and not just 4, but 4 plus 2, right? This 4 here, 2 here. But now look at these boxes on the outside. Now maybe you're taking this whole expression, right, this entire array, and dividing it into two groups. One group here, another group here. And we can see that division is kind of, at the end there because we're dividing this entire set, this entire array. And so again, it's not that we want to do one of these operations before another because of some, rules from above, but because look at the picture and look what it's telling us and how we can make sense of it.